Okay, so 2 weeks ago, Gao Wei mentioned something during her sharing. She asked whether do chefs cook at home. So it makes me think a bit on this question because similarly, do software engineers develop software at home? Uh, or more relevant to us, do front-end developers build websites at home? Or do app developers build app at home? So I think we can stop and think about this question. I don't have an answer for this.
That was the same intention.
Yeah. So I'm not here to judge anyone. There's no judging at all. I'm just just here to talk about what I felt after that, like what was in my mind. So I've seen some food reality show where it's very common to see during food reality show there's a chef traveling around the world to discover different kind of recipes from various cultures like Chinese cuisine, Japanese cuisine and stuff like that. And it's common to see them like sometimes go to a very rural area, a rural part of the world to uncover like the origin of the food or like some sort of secret recipe. So and it's also interesting to see how food evolves around the world, adapting and evolving. So I would like to by the same token, as a software developer, I think it's also important for us to travel around the world, which is like going like travel around the internet to discover different kind of frameworks or libraries that's out there. I mean, besides learning what we are already using right now, it's interesting for us. It's also interesting to look around to see what's out there, like different frameworks like Angular or Vue.js that we are not using. And also it's very interesting to go to find like the origin of these libraries. Like it doesn't happen from thin air, it comes from somewhere. And so that's what I want to bring up today, which is let's talk about like history of web development. And so history definition is a whole series of events. So there's a lot of things happening through the web development world that leads us to what we have and what we are today. So there's a lot of things happening in different aspects. So I'm not going to cover like everything in one go. We'll just focus on a small part of the like one timeline of the history, which is about JS modules. Okay, so let's have a background about what is a module. So this is what I found out from Stack Overflow. The definition, like someone asked, what's the definition of a module? So module, for what we know, it encapsulates code and data and logic within something. We call it a module, and it provides interface for people to use it. And because it's packaged in one module, you can simply use it like plug into any different kind of code and use it, right? So in most programming language, in most cases, usually we thought of one file is one module, and sometimes multiple files grouped together to become like one library module. So how the concept of module developed in the web development world. Okay, so let's go back to the very early days where once upon a time in a vanilla JavaScript world, like long ago, where we don't have all the tools we have right now. When you want to build a website, you need some people think like, I need jQuery, right? So what do? You go to jQuery website and you go to download jQuery. So there's a button called download jQuery. You click it, you will download a file called jQuery.min, and then you include it. So you include it. You create a script tag and then you include it in your HTML. You add it to the very last of the, like at the very end of your body, because a JavaScript tag is rendering blocking, meaning it will block rendering so you add it at the very end, so at least you have like rendered all the contents up there before you execute the script, right? And then this is your, so after you include jQuery, you include your code, which have something similar like this. Like you use jQuery, so jQuery is a $sign and you use $sign everywhere in your code. So as you can see here, $sign is available in a global scope, right? You don't have to import anything, it's there, but as long as you include jQuery file, it's there. So dollar is in a global scope. So right now, let's look at if we want to write another module in today's term, where we create another file, and then we create write our code like a utils, which is a circle utils, where you define a pi, you define area, you define circumference, right? And in index, you try to use it. So in the index.js file, you use area, you can get your answer. You use circumference, you can get, and then you use pi, and it's there also, because all of these are in a global scope, right? So what do you do if you want a local scope? Like for example, you want to make pi like a private variable within the within a file. You can only do it by this, which is the IIFE, immediately invoke function expression. So what you do is that you create a function, and then you return what you want to expose outside, and then pi is declared within a function, so it's a local within a function, local function scope. It's not available outside. So right now, if you use you can use like circle.something, right? But then if you try to look for pi, you will throw that pi is not defined, right? And you have to be careful when you do this, is that pi, if you forget to type var, then this pi will be in a global scope, right? So the only way to work around this is to use strict, which is by default right now for most of cases. So if you don't use var, use variable that you never define with a var, it will throw an error. Okay, so this is how you develop, right, in the early days, right? So in summary, we have a few problems here. So meaning we have a few problems. First off is that if we want to install libraries, we install it by go to the website, download, and include it to our index.html. Okay. Secondly, we don't import things, right? So anything that you include in index.html is globally available, and everything is in a global scope, right? You don't have clear defined boundaries within each file. Like one file is not a module itself per se, because everything you declare there is freely available throughout the application. Right, so I summarized the problems into 3 words. So installability is like how easy it is to install stuff. Importability is how easy it is to import things, and I don't think there's a word called scopability, but I just made it out like, so it's to how good is it to scope the variables and functions within each module. Like how does it, like, it will be good if it's scoped within a local scope and you only export things that you want to export. So let's look each of the problems one by one throughout the history. Like it's around 2010-ish until now, and like what has happened throughout this for the past 10 years, and how did we solve all these 3 problems. Right? So the first problem is installability, which is how easy it is to install something. So I mentioned earlier, what you can do here is just to click here and download and install, right? And if you want to upgrade or you want to downgrade to a specific version, you have to like find in the website and go to look for a specific version and click download for that version. One thing you can do instead of this is that you can use some CDN website, which is when you click, you can look for jQuery, and then you can I'm not it. I think you can look for different versions, but I can't remember how. And then just copy, and then you already have the thing that you can immediately paste to the website. Okay. So fast forward a bit, in 2009, which was like Node.js was first released by Ryan Dow, and in the following year, this guy called Isaac Schluter created npm, which is a Node.js package manager. So with npm, now you can simply call npm install and install something into your project folder, and I think it solves most of the problems already. But if you think this is the end of it, it's not really quite though. Because npm is designed for Node.js, and Node.js runs in server. So somehow, within the next year, there's someone created Bower, which is a package manager for the web. So it's a slightly different. So why is Node.js, the npm, not working for the browser, for the web? It's because I think for some reason, when you for most of the libraries that's written and published to npm is using this thing called CommonJS, which derives require and module.exports, which is not a syntax available to the browser. Okay, so it's not immediately available. So that's why there's people creating a Bower, which is a registry that contains only pure browser libraries. So what you do is that it's very common back in those days that you see a project setup that has a Bower.json and package.json. So you install browser dependency with Bower.json, which is a Bower install, and you also have dev dependencies, back then like build tools and stuff, installed in package.json, which you install by npm install. And then here is like how you, so Bower dependency will installs into Bower components, and here is how you include them in your application. So back then there's this like it's common to have Bower and npm coexist together in a project. Until we develop newer tools to make us slowly transition to just use npm, and that tool is called a Browserify. Although now I don't think a lot of people is using it now, but Browserify says that it lets you use require modules in a browser. So previously I mentioned most of the libraries that you publish in npm uses require and module exports, right? And that's why we don't usually install stuff in npm that to use it in a browser. But now with Browserify, it's something like a Webpack that you can that will look through all the files and combine them together and then bundle it to one file, right? So, and then slowly on we move to Webpack, and now, so this is like today now, when we want to install something, it's very easy, as we just call npm install a version, a module and a version, and then it just install. And you want to upgrade it, you just type a new version and install, and it's there, and you can use it easily. So the next problem I want to cover is the importability, which is how easy to import stuff, like to import and export stuff between modules. So as I mentioned earlier, you share everything through global scope, right? But life is actually easy. Global scope is not that bad because life was still okay back then. where front-end application, right, is mostly server-side rendering, like the whole website is rendered, and JavaScript code is just to attach event listeners and act upon interactions, to provide interactions. And pages are usually a multi-page application, so when you go to a next page, everything that you put in the global scope will be get cleared, and you don't pollute anything. It only gets bad because when it only starts to become a problem when we have more and more code that's being executed on client side, and we start to have a single page application or more complex application where we need to compartmentalize variables and functions within modules and don't let it pollute the global scope. So how do we solve this problem? So it all started with Node.js first. So we've got some inspiration from Node.js. So Node.js, when we have Node.js, there's something they call that something comes with Node.js, which is the module system within a Node.js. Because in Node.js context, right, there's no index.html that you want to that you can run, or that you can insert all the libraries that you want, right? So there's no way to include library code into to require libraries code, because previously we add it in the index.html and then we can use it, but in Node.js context there's no such things. So when you want to write a more complicated application, you have to have a module system like just other general programming language where you can import stuff and export stuff. So CommonJS is the module system that was created after then to solve the problem. So there's a interesting quote that I want to quote, which is at that point of time in JSConf EU 2009, this guy Kevin Dagger was saying that so the problem that I mentioned earlier, which is the module system, is not a technical problem. But it's a matter that getting everyone to follow a CommonJS specification, so we can step forward and start building modules and something bigger together. Okay, so CommonJS defines the specification of this, which is the require and exports. Right, so when you require circle, you get a circle, and then you can use it, right? So if you scrutinize at this code, right, you'll notice something, which is that require is synchronous. So meaning when you do require a circle, what happens is that Node.js will read the content of circle and then eval the content and then returns you what is being assigned to the export. All these steps are being executed synchronously, right? But then imagine what would happen if you have this in browser. When you want to require circle.js file, you have to fetch the content, right? You have to fetch it through the network. So it can't be synchronous, or else you're just blocking the main thread, right? It has to be asynchronous. It has to be something that looks like this, like require circle.js and then you pass in a callback function. So require require solves the problem of when you in a Node.js environment, but it's not a solution for a browser environment. So let me pause a bit here, and then we talk about something which is called the script loaders. So at that point, there's some libraries was created that they call script loaders, which you can load JavaScript files dynamically and then a callback function when this files is being loaded. So if you look at like a website, there's actually a lot of libraries, like script loaders library back then. This was like 2016, I think. So why is that so? Because script loader is actually a very simple utility that does something like this. So this is like the gist of a script loader. So what happens is that you have a load function right here. You pass in a URL. What it does is that you will just create a script tag and then you append that script tag to a document. And then when that script tag is finished loading, you just call the callback function. Right? So script loader was created back then to dynamically load JavaScript files into browser. So if you look here, load script and then you have callback. And this looks very familiar with what we have right now, which is our dynamic import syntax, which is import something and then with a then callback, right? And in fact, it's actually the same thing if you look into Webpack's dynamic import. The implementation is the same, is to dynamically load a JavaScript file and then when it's done, you call the callback. Right. So, as I mentioned earlier, asynchronicity is a problem in browser context, right? So, in order to have a module system in browser, we have to take in consideration of the asynchronous of the browser, and that's how asynchronous module definition was come about. So AMD. So how AMD looks like is that it's a definite the AMD specification defines that the define function is always available in the global scope, and you can have an ID, you can have a list of dependencies, and factory is the callback function. So what happens here is that you can define a module and then you return the module definition here. Whatever you specify in the dependency list will be available in the function callback, and then you can use it here. So AMD is a spec, and there's a lot of implementation of it. So require.js here, what we see here is one of the implementation. Okay. So after that, what happens next is that in 2011, we have this Browserify, which, wait, let me step back a bit. Okay, so with this AMD.js definition, you can now create like all this as a different file, and when you want it, you can just so this is something like what we call a require, and then you can use it here. Right, but when you still use a define function, what happens is that when Browserify comes about, it will bundle all the files into one. So you don't have to write a define function by yourself. You can use require. And what happens under the hood, it's something like this. So you have all the module names, and then this is the code that you write. So it will wrap everything, like every file within a function, and then you can use require module and exports. Right. So what require does is that it will try to call this function and then returns what is being returned from the exports. So now we have like two ways of doing to have two different kind of module system in browser, which is the CommonJS and AMD. Right. So that was back then. And in 2015, what happened is that we have ES 2015, which is the ES Harmony, which is a ES6 modules. So what happens after that is we now can because to unify the two different competing specification, we come up with a ES6 specification, which right now we can write imports and export segments, and we have but then this is still not a valid syntax in browser, so we have a bundling tool called Webpack, which will actually transpile that code back to something similar that you see that was done by the Browserify, which is it will bundle everything that into something that looks similar to this. So this was what happened in this timeline, where how imports and exports comes about throughout the past 10 years. So last problem I have here is the scopability. So you mentioned earlier, everything is in global scope. Right? If you want local scope, you can only do it by IIFE. So if you have a library that you want to export a $, because jQuery is already exported a $, and you have another library that wants to do that, you're out of luck, right? Basically, you have two competing libraries that uses the same global variable. So there's a few solutions that comes out. So one of it is, I would like to mention here is the Google Closure tools, like the way that Google Closure solved this problem. So if you go to the website, you will find something like this. Google provides something and then require. So what this does is that when Google Closure tool compile this whole thing, it will turns into something like this. Right, so Google Provide will turns into something like this. We will make sure that tutorial.notepad is a valid object, and if you require something, it will hint the tools to include the definition of google.dom in the bundle code. So you can now write your code like tutorial.notepad.something, and there's no so if you see here, everything is still in global scope, but then there's no conflicting between the global scope because you namespace the exported values. You manually create you have to make sure that this name is something unique, that you namespace all the exported values, so there will be no conflicts. Right, so that was the solution provided by Google Closure tools. And on the other hand, as we have seen earlier, the AMD solution, which is you can now here, right, when you define like libraries, so for those who don't know, Lodash is similar to underscore, where it will export Lodash or underscore, which is underscore, sorry, yeah. So now with this, right, you can actually, because all these dependencies will be injected to this function callback, so you can name it however you want. You won't have to worry about these two libraries are exporting on the same global variables, because you can name whatever you want, right? And that's how we end up right now today. We can require something, and then we name it to a variable that we want, so we don't have to worry about what variables that this libraries is defined on. There's no conflicting on the global scope, right? So these two tools that we use, and mostly we are using Webpack right now, we don't have to worry about polluting global scope. So there's one bundler that I would like to mention is Rollup.js. So for Rollup.js, for everything you define in a module, it's actually being defined in a global scope. So what I want to say is that if you look here, like you have two files, two modules, Circle.js and Main.js. if you write this, right, like a normal ES6 module system, what happens if when you pass through rollup, you'll be bundled into something like this, area, circumference, and then you can immediately use it. So everything here is in global scope, and it will be slightly faster because you don't have a lot of functions that encapsulate those scopes, right? But what happens if you have two modules that is going to export the same function name, areas and area here, right? So what happens is that when this get compiled or bundled, it turns into something like this. So Rollup.js itself will know that there's a naming conflict and will try to make two different identifiers, and then there will be no conflicts in the name. So although everything is in a global scope is not evil if you can control it, right? So in summary, these are the three problems that I've mentioned earlier, and what happened throughout the history for the past 10 years, and how we solve the problems we have encountered along the way. There's some reference that I was referring while preparing the slides, and have to thank these people that they have provided me some suggestions during the dry run. Yeah. So thank you.